Hello students, welcome to my YouTube channel RD Academy. So in this video we will be discussing another important 5 marks question from the electric charges and fields chapter. The question is like, find the net electric field due to a dipole along a equatorial line. Okay, so previously we have discussed the net electric field due to dipole along an axial line, but now we need to discuss along an equatorial line. Okay, so before going into the derivation, we need to look at the few prerequisite topics that we need from mathematics to understand this. Okay, first one is a mathematical concept known as alternate angles. I hope you remember what is alternate angles. Okay, suppose you have two parallel lines. Any line that bisects these two parallel lines like this, how will you identify the two alternate angles? It will be in the shape of Z. Okay, for example, this angle 1 and 2 are a pair of alternate angles. Similarly, we need to know what is corresponding angles. Okay, now in this same diagram, if 1 and 2 are alternate angles, you can see they are in the form of Z. How will you identify a pair of corresponding angles? This one, this 3 and this 2 are a pair of corresponding angles, and a pair of corresponding angles are always equal. Okay, so in this diagram I can directly write angle 1 is equal to angle 2 because they are a pair of alternate angles, and I can also write angle 2 is equal to angle 3 since they are a pair of corresponding angles. Okay, so this is the first prerequisite that you need to know. Next, we need to know what is vector resolution. Okay, now assume you have a xy plane. Okay, so in this xy plane you have a vector A like this, making an angle theta with the positive x-axis. So your vector resolution tells you that the component of A vector along x direction, we will call it as Ax. What is Ax? Component of A vector along x direction, and component of A vector along y direction, we will call it as Ay. Now how will you find what is Ay? Now look at this triangle. This is an right angle triangle. So in this triangle, if this is angle theta, this is angle 90 degree, then this side is adjacent side, right? So if I write cos theta in the triangle, it will be this length, that is Ax divided by hypotenuse length. Now the hypotenuse is nothing but the vector A, so it's just the magnitude of vector A, or I can write it as Ax by capital A, where this A indicates the magnitude of the vector A. Okay, so this implies x component of vector A is equal to A cos theta, just cross multiply. Okay, so I can directly write A cos theta. Now these two are parallel lines, right? So if this angle is theta, this is also theta. Now if you consider this inverted right angle triangle, this side is opposite to this angle. Applying the same idea, we can prove that Ay is equal to A sin theta. Okay, so just remember which component lies along which axis. That is the most important thing here. Okay, if this is the angle theta, then along x-axis you will have A cos theta, along y-axis you will have A sin theta. Fine. Now if you have, let us say in a xy plane, if you have two vectors of equal magnitude like this, okay, you have two vectors of equal magnitude and this angle is theta, then this A component along this direction is A cos theta and y component is A sin theta. Similarly, the B component along this direction is B cos theta, along this direction it is B sin theta. Now can you see one thing? This A sin theta and B sin theta are equal in magnitude, provided I assume magnitude of vector A is equal to magnitude of vector B. These two are equal in magnitude, but they are opposite in direction. Hence what happens? They will cancel each other. Okay, but along x direction now you have two vectors. One is A cos theta and another one is in the same direction you have b cos theta. So what is the total vector? Sum of the individual vectors. So the addition of these two is a cos theta plus b cos theta. Provided a vector is equal to b vector, then I can write it as 2a cos theta. Okay, you just need to have the idea of how these vectors or components are getting cancelled and how one component is getting added to understand this derivation. Okay, so these are the prerequisites that you need to know. Now we will start with the actual derivation. Now let us draw a brief diagram. Assume you have a positive charge, you have a negative charge, separated by what distance? I already told you the dipoles are separated by a distance 2a. Let this point O be the center of the dipole. Okay, now any point on this horizontal line, if you extend this way and this way, any point on the horizontal line is called as axial point and the line is called as axial line. Now to find out which is the equatorial line, you draw a perpendicular line to the midpoint of the dipole. Okay, so this is known as equatorial line and any point on this line is known as equatorial point. Now I need to find what is the equatorial point at this point P due to this plus charge and due to this minus charge. Okay, so after writing this diagram, explain few words about this diagram. Okay, consider a dipole consisting of plus charge and negative charge minus q separated by the distance 2a. Okay, point P is an equatorial point located at a distance r from the center of the dipole. Fine. So what will be this distance from the center of the dipole to the positive charge? This will be a and this will be a. Okay, so total length is 2a. Now this positive charge exerts some electric field at this point, right? What will that be? Draw one straight line from positive charge to that point. Now you already know the electric field line around a positive charge is radially outward. So this will be the direction of electric field due to positive charge. And what will we call that as? We call this as electric field due to positive charge plus q. Okay, now similarly, what will be the electric field at this point due to this negative charge? Draw one straight line. This vector we call it as electric field due to negative charge at this point. Okay, all the negative charge will pull the objects, positive charge will repel the positive charge it is radially outward, for negative charge it is radially convergent. From Coulomb's law, this vector should always lie on the line joining the 2 points where you are considering. Here plus charge q and point P, this is the line joining. This vector should lie on this line. Okay, since it is positive, I have drawn in this particular direction. Fine. Now now if you can see, just imagine the xy coordinate system here. Let me draw one x y coordinate system. Now in an equilateral triangle like this, in an equilateral triangle, if this angle is theta, this angle is also theta. Why is that? Go back to the prerequisites. These two are in the shape of f, right? These two angles are in the shape of f like this. So they are a pair of corresponding angles, hence they should be equal. Okay, we don't know what is this angle. Let us call it as theta. So if this is theta, this should also be theta. Now, can you resolve this vector into two components? Now, you have electric field due to plus q, that is the vector in place of a. Now, which component will lie along this line? Which component will lie along this line? Now, since for this side is adjacent to this theta, write down the magnitude of this vector. I will write it as E plus Q. I won't write the vector symbol. It indicates just magnitude. Cos theta is the component lying along this direction, whereas in this direction you have E plus Q sin theta. Okay. Similarly, consider this one. Now, if this angle is theta in the triangle we are considering, this angle is also theta. Why is that? They are a pair of alternate angles, right? They are in the shape of Z if you see. So if this is theta, this should also be theta. Now consider this vector E minus q vector. For E minus q vector, this side is adjacent, this side is opposite. So which vector will lie in this direction? You have the main vector E minus q, magnitude of that cos theta, that will be along this direction. Along this direction you will have E minus q sin theta. Okay, I hope I am clear in this one. Now you can directly tell that E plus q sin theta and E minus q sin theta are equal in magnitude, but they are opposite in direction, hence they are getting cancelled. Okay, and in this triangle, if this length is r and this length is a, what will be the hypotenuse length in both the cases? The length of the hypotenuse, that is, let us call this as point A, point B. The length of the hypotenuse AP is equal to BP is equal to square root of r square plus a square, or I can also write it as r square plus a square whole power 1 by 2. Okay, so keep the diagram in clearly, draw the diagram neatly. You need to indicate the vector, you need to write this 2 arrow mark because it indicates there are 2 vectors in the same direction. Here also you need to compulsory write the arrow marks. Okay, diagram carries 1 mark. Now we will move to the mathematical part of this derivation. Okay, now tell me the magnitude of electric field due to plus q. It is equal to k, which is nothing but your 1 by 4 pi epsilon naught. The magnitude of positive charge is plus q, kq. Now look at the diagram. What is this distance between the point you are considering and the positive charge? It is this AP, kq by AP square, right? So this is equal to kq by, what is AP equal to? R square plus a square whole power 1 by 2. So r square plus a square whole power 1 by 2. Again whole square is there, so this square and square root will get cancelled. So ultimately you will have kq divided by r square plus a square. This is electric field due to positive charge. Now consider electric field due to negative charge. It is equal to your 1 by 4 pi epsilon naught. I will write it as k. Magnitude of negative charge is q. Now what is the distance between negative charge and the point you are considering? The negative charge is located at point B. The equatorial point is point B. So it is BP square. Okay. So if you simplify, KQ is equal to, I have already shown you that AP is equal to BP is equal to root R square plus A square. So it is root R square plus A square whole power 1 by 2 whole square. Okay, so now here square and square root will get cancelled. Ultimately you will have kq by r square plus a square. Fine. Now can you see both magnitude of E plus q and E minus q are equal? So you can say that these two vectors E plus q and E minus q, they won't matter, and sin theta is also same. So they are equal in magnitude but opposite in direction. Here both vectors are in same direction. Okay, so now that point is very important. You need to write here resolving electric field due to positive charge and electric field due to negative charge. We see E plus q sin theta and E minus q sin theta are equal in magnitude. They are equal in magnitude but opposite in direction, hence they cancel. But E plus q cos theta and E minus q cos theta are along same direction, hence they will get added. Okay, now can you tell me what is the net electric field at point P? It is nothing but E plus q sin theta sorry, E plus Q cos theta plus E minus Q cos theta. We have already proved that E plus Q is equal to E minus Q. Okay, so I will write it as 1, any one of the quantity. Substituting E minus Q as E plus Q, I will get it as 2 E plus Q cos theta. Fine. Now substitute the value of E plus Q. Here you have E plus Q is equal to KQ by R square plus A square. 2 into KQ by R square plus A square into cos theta. Okay, so I'll continue in the next page. So previously we had net electric field at point P is equal to 2KQ by R square plus A square into cos theta. Now I will draw the rough diagram in the previous situation here. Okay, so you had this triangle, right? You had this triangle, this angle was theta, this angle was theta. What was this length? If this is O, this is point B where negative charge is located. This distance is your A, okay, and this distance is your R. What is the length of the hypotenuse? R square plus A square. Now just directly write what is cos theta by looking at this triangle. So if this is theta, cos theta is adjacent by hypotenuse. Adjacent is this side OB. The magnitude is A. So A divided by hypotenuse is R square plus A square. That I will write it as R square plus A square whole power 1 by 2. So if you simplify further, you will get 2KQA divided by R square plus A square. Here you have 1. Okay, bases are same. A power m into A power n is A power m plus n. So 1 plus 1 by 2, you will get it as 3 by 2. So I will directly write it as 3 by 2. So this is the magnitude of net electric field at point P. But I have not dealt with the direction. This just represents the magnitude, right? Now look at the diagram. We saw that these y components are getting cancelled. The net electric field due to dipole is along this particular direction. But what is the direction of dipole moment? Dipole moment always starts from negative charge and it moves towards positive charge. This is P vector, but this is your E vector. So they are opposite in direction. Okay. So here if you add the direction, the net electric field is nothing but minus P cap. Okay, so this negative symbol indicates it is opposite in direction to the unit vector along dipole moment. Okay, so if the dipole moment is in this direction, the net electric field along any equatorial point will be along this direction. Fine, I hope I am clear. After writing this expression, just explain all the terms. Okay, now moving forward, we need to simplify this for the case of short dipole. Now what is a short dipole? A short dipole is one for which the distance at the equatorial point is much greater than the distance between the dipole. Okay, now here you are considering, no, here you had dipole and here you had the equatorial point. This distance was r and this distance was 2a. Consider this r at a very large point. This r, when it is significantly greater than a, you can ignore this a, the smaller quantity. Okay, so if I'm substituting that, the net electric field along equatorial point is 2 times. I'll write k as 1 by 4 pi epsilon naught into qa divided by, in this r square plus a square at very large distances. This expression reduces to r square whole power 3 by 2. Okay, here you have that a square whole power 3 by 2, but since a is very small quantity, we can ignore this a square and a power 3 by 2. Okay, so it will be 2 times 1 by 4 pi epsilon naught into q divided by, this one will be this 2 and 2 will get cancelled, q by r cube. So 2, this whole quantity is k, q divided by r cube, direction is minus p cap. This is the net electric field due to dipole along any equatorial point. Okay. So this derivation is one of the most important derivation from your examination point of view. So make sure you study this very well enough. I hope I am understand. We will see in the next video. Thank you.